Okay, this recording is to help you with lesson 6.01, Law of Sines. Now, Law of Sines is set up like a proportion. So if you can solve proportions, you should do okay with this lesson. Now, the proportion can be set up a couple different ways. You can have your sine of A or your sine in the numerator, or you can have your sine in the denominator. As long as you're consistent, it doesn't really matter which way you solve it or set it up. Okay, so what we're going to do is, you notice you're always given an angle and a side of the same there. So we're given angle A and side A. So that's going to be our first fraction, and however you set it up is up to you. If you want to do sine in the top, fine. I usually do my sides in the top, so that would be side A over sine of A, and A I know is 36 degrees. And then we're going to set it equal to B and then C and find those missing parts. Now, the side B we know is 5, but we don't know angle B. So I have to put sine B here. So I'm going to cross multiply and then solve. So 8 times sine B equals 5 times sine of 36. And then divide each side by 8. Okay, this is going to give you a decimal answer. And let's see exactly what it gives me here. So 5 sine of 36 divided by 8 gives me about 0.367, somewhere around there. To find the actual angle measure, remember you have to take the inverse. The sine inverse of B. And make sure you are in degree mode. If you are not in degree mode, you will not get the correct measure. It won't even look right because it'll just look like a decimal answer. We should get about 21.55 degrees, depending on how you round there. So somewhere around there. So there's angle B. Now to find angle C, you're going to have to use your triangle sum theorem, and that is subtracting each angle A and angle B from 180. So to find angle C, you have to do 180 minus 36 minus 21.55. And that gives me my 122.45. And then to find your last side, that's side C, you have to set up another proportion. Look, if they already solved for C in their proportion here, and that's okay. Otherwise, you can solve it like this, only you'd have side, instead of 5, we're looking for side C, and we know that angle C is your 122.45. So you can set up your proportion that way to help you solve. Doing that, we get about 11.49 or 11.5. Right, in the next one, we have A, B, and big angle B here. I'm going to write this as just a decimal. This is 5.5 degrees. Remember, 30 minutes is really 30 over 60. So if we were to reduce that or put it in decimal form, it'd be 0.5. So that's how I get the 15.5. Okay, setting up the proportion, looks like they wanted to solve for angle A first, and that's what we need to do. So they just solve for angle A in their proportion already. Again, you can set it up like this instead, 6.8 over sine of 15.5 equals, we have 4.5 over sine A. So cross multiply, solve, and then remember to get the actual degree measure, you're going to have to take sine inverse of that decimal answer that you get there. So angle A should be about 10 degrees, 11 minutes. Let's see exactly what that would be as a decimal. Oh, it's somewhere around 10.18. So if we use 10.18 here, that's okay for angle A. For angle C, just subtract from 180 then. So 180 minus 15.5 minus 10.18 gives me, let's see, 15.5. It gives me about 154.32 as a decimal there. You don't have to leave your answers written in minutes. Decimals with degrees are fine. And then they just set up their last proportion here. So instead of having 4.5 over sine A, we can change that second fraction. We're looking for side C, and that would be over sine of 154.32. And just cross multiply and solve that way. We should get about 11.03 for side C. All right, we have to be careful because there may be two triangle solutions that actually exist here. All right, so usually when we have side-side angle, that's when we have to be careful. Okay, especially if we're able to solve and get a value for B. Okay, so here I took this straight from the lesson down here. Sometimes there's no extra triangle, and fine because you get an error message, and that's great. You know there's only one answer. However, if the calculator gives you a value for the measured angle B, we have to be cautious, right? So unless we have tested the side opposite the given angle using the chart, which they took from the lesson, you're not going to know if there's two triangles. This happens because the sine function is actually positive in your first and your second quadrant. All right, your calculator only takes the very first answer it sees, and that's always in the first quadrant. So the calculator is neglecting to tell you that additional information that, hey, there's another value for it in the second quadrant too. Okay, your calculator does not do that for you, so you have to be physically aware of that second option. Okay, you can find that second option by subtracting the angle that the calculator gives you from 180. Okay, so you're actually finding that reference angle. Remember when we talked about reference angle in semester 1? This is what we're using it for, to find that second possibility now. Okay? And then you always need to make sure that that angle that you found plus the angle that was given to you in the problem doesn't add up to more than 180. If it adds up to more than 180, it's an extraneous solution. It's not going to work. You can't make a triangle. We forget about it, and then we move on. Okay, so here's an example where there's actually two solutions, two different triangles that we can make. Okay, so here we would solve for angle B. In angle B, we notice we would get, okay, 0.9423. Actual angle is 70.4. Okay, so what we would do then is we're going to take 180 minus 70.4. And that's where we get the 109.6. So really, you could have it be 70.4 or 109.6. What you need to be sure of is that 109.6 plus the angle that's given to you of 58 here does not add up to more than 180. Sometimes it's going to add up to more than 180, and we can just forget about that second option. It's not even a choice then. And here, it does not add up to more than 180. So we do have that possibility that that second triangle exists. So from here, we're going to take it a case-by-case basis. And we're going to say, well, case 1, let's have angle B be the 70.4 degrees. That's what we originally found it to be. Okay? So if that's the case, we can find angle C by subtracting those from 180, and then we can set up a proportion to help us solve for side C. Okay? So you're using that information there. Now, you can say, or I can have case 2, where angle B is really your 109.6. If that's the case, then angle C is going to be 12.4, and then using my proportion to solve, side C is going to be 1.14. Okay? So we really have to be careful of those. So here there actually are two cases. Okay, let's look at the next one here. A flagpole is located on a slope that makes an angle of 12 degrees with the horizontal. The pole casts a 16-meter shadow up the slope when the angle of elevation of the sum is 20. Okay, so draw a triangle that represents the problem. This is really difficult. Anytime you're dealing with angles of elevation or depression, it can get a little bit confusing. So here's the triangle that we're actually going to set up. Okay, so here is the 12 degrees of angle of elevation. Right? And then your 20 degrees up here is your angle of elevation. This is actually angle of depression, but an angle of elevation up here. Okay, so then we can get 32 and 70 degrees. And now we have to solve. Alright, so setting up your proportion, let's take a side and set it over the opposite angle. So 16 over sine 70 equals side h, which we're trying to solve for, over sine of 32. When we cross multiply, we get h times sine of 70 equals 16 times sine of 32. Divide each side by sine 70 to get approximately 9 meters then. So the next one here, we have this plane and we have basically this triangle that's drawn. We need to find the bearing of the flight from C to A. So the bearing is actually talking about this angle right in here. In order to find that angle, we need to find angle A. Okay. So angle A, we can find that by setting up a proportion. And I did 720 over sine of 46 equals 500 over sine of A. I cross-multiplied and divided, and then I did sine inverse to actually find the degrees of angle A. So angle A in here is 29.97 degrees. Right? Now, right here to find your bearing, those make right angles. So in order to find the actual bearing there, or the degrees up here, we need to subtract angle A from 90 degrees. So 90 minus 29.97 gives us our 60.03. So the bearing there is actually south 60.03 west. Now if you just say the 60.03 degrees, I'm fine with that. You do not need to include the southwest there, which are actually the bearing part. I'm mainly interested in, can you get that 60.03 degrees? So that's how we're able to do that. And the last thing that they talk about in lesson 1 is to find the area of a triangle. And we can do that using any of multiple formulas. Usually it's 1/2 times the 2 sides you're given. All right, and then multiply that by the sine of the excluded angle. So notice you're given side BC. You should be taking sine of angle A. Okay, so BC sine A. And it always follows that pattern. So if you have side AB, you should be taking sine of angle C. Always kind of follows that pattern there. So all we need to do is plug the information into our formula and then solve. Again, we can change this to a decimal if we want. 45 minutes over 60. So 45 divided by 60 is 0.75. So if we want to put that as a decimal, angle A is really 43.75 degrees. So you do have that option there for you. Okay, so putting that all in, the area of that triangle is actually 1,675.2 units squared.